Blades to be knives, machining and welding. Let's get after it. Hey YouTube, welcome back to the Blades to Be shop and another project video. I know it's been a little while since I got some videos out, but I've been at the Blade Show in Atlanta. Had a great time there, so appreciate all of you who stopped by the table in Atlanta. Got a few knives out the door, and now it's time to catch up on some other projects here in the shop. So pretty fun project today. I think it's going to be a good mix of some manual machining on the lathe, and then we've got a little bit of CNC work to do on it as well. So today we're working on making this, it's kind of a screw type puller. I know, sort of an odd little part here. We've got a base plate, little screw thread on it, some pointy bolts sticking through, and then there is a drill chuck that is going to mount on the front of that. This one's not drilled and tapped to the right size yet, but this drill chuck goes on there, and basically you can clamp onto a shaft and you sort of got a reverse screw puller is what this is. Customers looking to sell these, so that's about as much proprietary information as I'm going to give you on it at this point. But again, that's pretty much the fun of being a machinist, right? Sometimes you're making parts, you don't always get to know exactly what they're for, but there is plenty to be learned in making a part without knowing exactly what it is supposed to do. The other fun part of this project, tried to help the customer really maximize where to save some money on this. So instead of, originally he was going to buy some tubing to thread on the outside and have that bore through the middle. Instead we got some threaded rod to save the cost a little bit on that. And obviously much cheaper to make this a two-part piece instead of one part, because we're making this all out of some stainless steel today. It is welded on the back, so I'm not going to be doing the welding. I'm working on some TIG welding, but I'm not quite ready for prime time to make a pretty TIG weld. So he's going to take that somewhere else, but we're making all the other pieces and we'll get these things all assembled and put together for him. So for those of you new to the channel, I appreciate you tuning in. I encourage you to get out there and check out the other videos on here on machining, welding, knife making, just everything else going on here in the Blades to Be shop. And if you like what you see, hey, go ahead, hit that subscribe button, hit the alert button, and you'll know when the next videos come out. All right, let's go ahead, turn this camera around, and let's start taking a look at all of our pieces and parts and material. Start digging into this and making some chips. Let's take a look. Alright, so for this base plate, we're just going to start with some 2 3/8 stainless steel. He ended up buying, I think, 400 series stainless is what we're going to work with. And the nice thing about this project is really there aren't any of the tolerances that are very tight or specific. So we're not even going to machine the outside. We'll probably just hit that with some emery when we're done and get all the scratches off it and have it look good. But we're just going to finish that outside to the 2 3/8. So really the machining in the lathe, we just need to get in there, machine this step on there, and drill and tap the center of it. So I'm going to first machine one end of this down for that little nub. So I'll face off one end, machine the nub, and then I'm going to turn it around and work my way across all the way from the other end. And that way when I get tight down here at this end and I don't have to try to grab a really thin lip in the 3-jaw, I'll be able to grab that 7/8 piece we're going to turn in the collet, and I'm going to try to maximize getting as many pieces out of here as I can. Overall width on this is 1/2 inch. We've got 6 inches of material. I'm going to be parting off in between, but I think I can still get maybe 7 or 8 total out of here. That's part of what we're figuring out here as well. The goal is to make as many as I can this time and really figure out how much time it takes to make one of these, and customer may need some more of these in the future. What I'm going to do afterwards is I'm going to take this piece of aluminum, I'm going to drill and tap a hole in there, stick a piece of this threaded rod. I'll be able to screw these down in the CNC, and I'll be able to drill and tap that bolt circle in the CNC. With one setup, I should be able to just unscrew, put the next one on, knock it out, and get that done. So there's our little mix of CNC. Get those base plates done. And then for the threaded piece, again, we bought this stainless threaded rod, a lot more cost effective than buying tubing and trying to thread the whole outside of that. So with this threaded rod, all we're gonna have to do is just drill a hole right through there. I'm gonna drill it a little bit undersized, and then we're pretty much just going to a 31/64 size. I'm gonna run that 31/64 in there almost like a reamer, and that'll be close enough on our tolerance. Once I know exactly what length I need on these, then I'll just cut these to length with the bandsaw. We'll stick them in a collet, and we're just gonna drill the hole through those. So that should go pretty quick. And then on these chucks, some of these with different size holes in them, but basically on this chuck, we need to drill this out and tap it the same size as our threaded rod here. So 5/8 11. So we're going to drill and tap that, end up with our hole all the way through. So this is the clearance size hole that we're drilling in the inside the ready rod. So I've got enough room inside there to drill all the way through. Obviously our tap drill size isn't going to go all the way through, or it would be hitting the jaws on there. But we're going to see exactly how far we can drill in there. And when we thread it, I've got a plug tap, but I'm probably going to grind one of those plug taps down a little bit on the end to get a couple of extra threads. And we're going to maximize how far I can thread these, and we'll make sure that we are leaving enough thread sticking out on these. We're maximizing how much room we have to, again, this is going to kind of unscrew to be a bit of a puller. So that's the plan. We're going to first drill and tap one of these, make sure I know how far I'm going to be able to thread it, and then we'll know where to cut our rod. Drill and tap all of those pieces, then we'll make our jig to get that done. The final step then is we've got to take all these bolts and we've got to turn those down to a point on there so that they sort of grab on our piece. So my plan for that is I'm going to take a piece of this aluminum, counterboard a little bit on the backside, get rid of some of the material, probably cut off about an inch or so of this, drill and tap that on the inside, and then I'm just going to put this back in and out of a collet all the time, put a screw in there, run in reverse, cut my point on that, pull it out of the collet, drop another screw in there, run it in reverse, do that. I thought about maybe doing those in the CNC as well, but I think it's going to be just as fast to do those in the manual lathe and turn our points on there. And we've got those screwed in from the backside. We'll be able to quickly sort of check depth on the front. We'll have a good face to do that and make sure we get some consistency. Get those all about the same length. We've got our 5/8 tap drill, got some 5/8 taps, got our 5/16 tap drill and taps to get those in once we set those up in the CNC. So I think we've got everything we need. We've got that reamer size to go in there. So that's pretty much the project. So kind of a good mix of different things. Sequence of events. First, I'm going to work on the chucks, get those all done. Make sure I know exactly how much thread I'm going to get inside of there. Once I know that, then I can cut all these pieces of ready rod down to length. And then once those are cut to length, we'll face them off, clean them up, get those drilled all the way through, put a nice bevel on the backside so they can run a nice bead to weld that together. So we'll get all the chucks done, we'll get all the rod done, and then we'll probably get in there and work on this. Maybe the screws next. We'll see where the time's going for today. But otherwise, we'll start working on the base plates, and then obviously we'll work on making a jig. We'll get the screws done, and the last step will be to get this over in the CNC. Drill and tap our plate, get that set up, go ahead and knock out the bolt circle and drill and tap those. Got a good drawing to work from in the lathe when we get to this piece, so we know where we're going with all our steps. But again, pretty forgiving on this. The goal is to visually make sure that these have some consistency and look the same, but pretty much plus or minus 5 thou is what we're dealing with on all these tolerances. Hopefully go pretty quick. The goal is to try to get good consistency, but also be able to knock these parts out fairly quickly. All right, let's go ahead and head over to the Precision Matthews lathe, and let's start working on drilling and tapping these chucks and see how that's going to go. See you over at the machine. All right, so I don't have a collet big enough to hold these in. I was hoping to hold these in the collet chuck. That's not going to work out. So we're going to go ahead and just hold those in the 3-job. All right, the other thing I did, since I'm going to be doing a lot of drilling for this project, I went ahead and put some coolant in my lathe. I haven't run coolant in this machine once yet, so that's going to be something a little bit new, but I think for this project it's going to warrant it. We're drilling a lot of holes between in the chucks, drilling through a lot of that ready rod, so I think it's going to be nice to have some coolant on here and give me a chance to see how the coolant works on this lathe, see how good the flow back is on it, how much mess it's going to make. We'll see how that all turns out. All right, let's get our tap drill in here. Not having a center drill or anything with these, they're already ready to go. We're just going to be punching that tap drill in here and then running the tap in here to get these things where we need them. All right, my tap drill is a tapered drill bit, so I'm going to just stack enough sleeves on this to get it up to the number 4 so that it fits in my tailstock. There we go, we got enough sleeves stacked on there. We got a number 4 Morse taper. All right, and I've only got so far I can get in there, so let's make sure we've got our depth set on this. All right, we want to go about 300 RPM. Let's see how we're doing with coolant. I'm running at about 250 right now. Oh, that's a little slow. There we go, now we're at 250. And let's see how our coolant is doing here. Okay, I think that should give us enough coolant. Yeah, let's see what I can find to keep some more of that coolant in check there. All right, I'm trying to come up with something here to block a little bit more of that coolant. We're going to be drilling for a while and don't need to have coolant just flying all over everywhere. Maybe once I get the collet chuck on there, it might be a little bit better, but we're still going to be doing a few of these. So seeing if I can come up with some way to hold this in place a little. Well, let's see how that's going to do. Rest there and hold in place a little bit. All right, well, the first one didn't take much because somebody's already tried to drill and tap that one once before. So we've got that one out where we need it to be. I think in order to get my tap to start nice, I think I'm going to go ahead and machine a little bit of a bevel on that as well. Okay, let's see how we're doing here. We'll sort of power tap this a little bit. And this one's a little weird because this one wasn't a clean hole. The other chucks are going to tap a little bit better than this one. We'll see how they're going to go, but this is kind of a hard example to get a sense of how this is going to go. It seems a little wobbly on us, but again, it's following some old threads in there. All right, well, we kind of got a sample to test fit. Again, we're threading into a hole that was already threaded once before. So a little hokey on this one, but I just want to see how far that's getting onto the shaft. So let me go get some air in there, clean this out. Let's see how we're doing, and then we'll knock out these other ones. I kind of want to use that tap a little bit before I grind the end off of it and turn it into a bottoming tap. So I think we're going to go ahead and drill and tap all these as far as I can, and I'll probably just finish them off by hand in a vise once we get all of them done. All right, let's check out where we're at. All right, well, it threads onto our ready rod, so that part is good. Yeah, definitely a long way from bottoming out. So right now, we're going in there just over 3/4 of an inch. So we really want to get another 1/4 of an inch for sure, maybe even just get to where we're a hair over 1 inch. So if I look at this tap, yeah, we definitely have partial threads on there. Yeah, we're almost 1/2 inch of partial threads on there. So by the time you got the bevel on the end of that. So I think we'll take this tap and we'll knock at least 3/8 of an inch off at the end of one of these. And then we should have a good bottoming tap and we should be able to gain that extra 1/4 of an inch in those holes. But before we do that, we're gonna go ahead and drill and tap those other chucks as far as we can. They should go a little smoother because we're drilling a clean hole in there. We're not gonna be messing with some old threads. So let's go ahead and punch into those and see how these ones work out. Cutting very nice this time. Not a partial thread, it's cutting properly. That's feeling great. All right, I think we're getting a bit of a process here now. So we got 5 more of these to go. I'm going to zoom in a little bit and get a better look at the next one here. But that is a nice looking thread we've got cut in there. Again, compare that to what we're starting with. Got that knocked out nicely. Good looking thread in there. And we've got enough room. I can get a good measurement on this one now that I've got the step out of it, but I can maybe even go another turn or so, another couple turns on that tap, even before I shorten it down to a plug tap. We'll kind of refine that, and let's knock the other 5 of these out, and then we'll move on to our next part. All right, that time I went right to the bottom of the tap. I figured I had a little bit of extra room. So we're all the way to the bottom. We'll make sure that didn't get too close to our jaws on the inside, and then we should have a good, repeatable spot to get to. All right, that is about perfect in there. So that's getting in there just far enough. It's just right at the back of those chuck jaws in there. I know you can't quite see all the way down in there, but that's threaded just to the perfect distance. If we grind a 1/4 inch off of that tap, we're really gonna get some good depth because Let's see, there was the mark I had on there before. Yeah, that gained us about another 1/8 of an inch. So there's our first mark at 0.773, so just a little over 3/4. And there's our new mark over here at 9/24. So yeah, that's perfect. We take another 1/4 of an inch off the end of that tap so we can run it in there a little bit further, and we're gonna have exactly what we want. Just a little over an inch of travel. It's gonna be awesome. All right, starting at just the first turn or so by hand really helped line that up a little straighter. I had one that, got in there walking a little bit, giving it that little bit, making sure you're pushed in there nice and tight before you give it power. Seems to make it just a little better. All right, we've got step 1 complete. We've got all 6 of those drilled and tapped. Actually 7, we've got that kind of ugly one. We got that in there too as our little practice. So we've got 7 of those drilled. We're gonna go ahead and finish tapping those by hand, but I'm gonna go ahead and move on and use this tap a little bit more before I modify it into a bottoming tap. So I was gonna work on drilling this rod out next and maybe even the screws. Since I've got the 3-jaw on and not the collet chuck, I think we're just gonna go ahead and move on to these face plates. So we're going to go ahead and chuck up that piece of stainless right there. We're going to get that in the 3-jaw, and like I say, I'm going to do first turn down the one end to that shoulder, get it faced and turned down to the end, and then we're going to turn it around and drill all the way through that piece, start our tapping the hole in there, and then we'll start just moving through and making as many of these as we can. All right, let's get that big chunk of stainless in the 3-jaw. All right, so we got this big 3-inch piece in here now. We're gonna face it. I'm gonna turn down my first step on there. I'm gonna try to minimize how many tool changes I need to do. I think I'm gonna switch that out and use this insert. So I should be able to face with this one, turn it in there, go in, machine out. It should be just enough angle. It'll be taking a cut all the way out off of that face. Yes, I think I can do all 3 operations with this. And then I'll just pop a boring bar on there to bevel that edge. And then we'll be putting the parting tool on there to part this off. All right, let me get a fresh insert on here, get ourselves in business. So, all right, so for this 2 3/8 stainless, I can turn it up to 900 RPM, it says. Actually, up to 1,000 RPM. We're gonna start at 900. We'll see how that's doing for us, and we will go from there. That didn't quite clean up, a little more. All right, so I just zeroed in on the center of my part. I just touched off on the outside. It's 2.375, so I wound in 2.375. that should get me pretty close. So I'm going to rough down to that 7/8 of an inch for my step. And I know I'm already zeroed and I'm going in 266. So I really want to go in about 260. And I think I'm going to use my depth stop here to make it faster to rough these out. All right, so I set up my depth stop on here so that I can just go in that 260 to 59/8 without even having to think about it. So I can quickly just get in there, rough back my step on that. And then when I'm finished, I'm gonna take my finish cut. I'll use power feed, I'll finish cut in, I'll change my depth to the 266, and then I'll take a nice finish facing cut all the way across there. And I should be able to turn the diameter, face that all the way off, kind of in one operation. So that'll be our last step. But let's go ahead and get this roughed out, and then we'll take that finish cut. All right, the other thing that's going to be nice on this lathe is when I take that finish cut, that's going to be my direction turning in for the finish cut. It's going towards the chuck. I can immediately change that to my cross feed, and it's going to be coming out. So without having to change any gears, I can be under power. I'm going to have power feed going towards the chuck for my outside diameter, and then I will have power feed coming out to do that finish facing cut. So should be a really nice operation. It should make these go pretty quick, but let's get this first one roughed off, and then we'll set up that last pass. All right, got to get used to the focus on this camera, but there we go. We got that first one done. We're at 7/8 on our step. We didn't touch the outside. Got our depth on there. Let me check that really quick. Yeah, 266, 2655, 266. Let's get this turned around. We should be able to knock these out pretty quick, I think. Let's see what our time is looking like on them. Well, there's one done. I just realized I'm not recording. I'm not sure when I stopped recording, so we maybe didn't get any of making this first one on there. But if that's the case, that's all right. We got a whole bunch more to make. So went pretty well. We got that roughed out. I left it a little thick when I parted it off, but it parted off pretty nicely. Used coolant to part it off. That worked great. So anyway, I think we missed that one, but let's jump in there. And we'll start again and make some more of these. So I've got a reset, so we're gonna see if we can knock out 2 in a row here is the plan. So I'm gonna face it off now that I just moved the material out. Basically, I drilled halfway through. I drilled 3.5 inches deep, so a little more than halfway. And we're just gonna tap as we go. So I've got enough, I'll tap these 2. We'll get both of them parted off. I'm gonna pull it back out, and then I should have enough I can drill the rest of the way through, and same thing, we'll just kind of keep tapping 1/2 inch at a time, make a part, tap 1/2 inch, make a part, and that's sort of the process. So right now I've got it set back up. I'm gonna face it off real quick, get my 0 set on the facing. All right, and for a speed, I started out at 900. That was tearing up my carbide pretty fast. So right now I'm running at 620, and we're gonna part it off at 380. That's our plan here.
Alright, so I thought I'd come back for a quick check-in before we get over to facing off the backside of these. So again, remember we cut the first step on the backside of this one, so I've got a piece back there. I'm down to where if I tried to pull that out of the chuck, I'd be, trying to hold on to about a 1/4 inch or so pretty minimal in order to get one. So I went ahead, I finished my last two. This would be the third one in here, so I went ahead and faced it. I don't have enough room to get in there and part it off, but I'm gonna switch over now from this 3-jaw chuck. I'm gonna put my collet chuck on here. I'm gonna grab the first one. I'm just gonna part it off, and then I should have enough material that I don't know that I can get 2 more out of there. So by the time I part it off, I think I'm just gonna be facing off maybe a 1/4 inch or so. So I'll probably just face off about a 1/4 inch of material, and then I will have that last one left. And that'll end up getting me 9 out of a 6-inch piece. So for a 1/2 inch part, facing off in between, parting, feel like that's pretty good, that I think I'll get 9 out of there. Don't think I'll have enough material to get 10, but let's go ahead and switch out to the collet chuck. We'll see how it holds that to part it, and then we'll face that last one off, and we should have 9 of these. All right, we got that collet chuck on here now. So pushes up right against that shoulder. Should hold that in there nice and square. And we should be able to get in there. I'm just gonna hit the emery on the outside of that, clean that up, and we'll get in there and run the parting tool and get that parted off. All right, not holding on to as much material, so I think I'm gonna go ahead and put my center in there just to make sure nothing gets away from us here.
parts off of there pretty clean. I still left enough room. I've got some that I can face off the back side of those, but definitely with a fresh insert in there, those part off pretty darn clean. All right, now that parts so well that I think instead of facing off 3/8 of an inch here, I think I'm just going to go ahead and part this from the other side. I think that'll be my fastest way to get rid of some material here. All right, a little hard to measure against my bevel, so give myself a little bit extra. And let's see, what do we have in left here for stock? About 350 thou left of material. So I think we did a pretty good job with that 6-inch piece of maximizing our material. And like I say, we're gonna end up with 9 of these out of here. Not bad at all. Let me just push my center up there close again. And let's just part off that last piece and we'll face off our first one. We'll start finishing off the back sides of all these. We'll be in good shape. There, nice little 3/8 piece of stainless left over. Let's get the tap through this one and then we'll start facing off and cleaning up the backside of all those other ones. All right, we'll give that outside a quick rub. Now the insides of all these need a good chamfer where we're going to run that weld on there. But man, this one little boring bar of mine, it's an awfully tight fit on here. So I think rather than change it every time, I'm going to face all 9 of these off and then I can bang them in and out of the collet really quick, change the boring bar once, and I'll go through and bevel all those at one time. So I think we'll skip that step for right now, put that facing tool back on there, and let's knock all these down to the right thickness, and then we'll chamfer all of them at the same time. Alright, well there's our 9 pieces done. We got 9 of those out of that 6-inch piece. So feeling pretty good about that. Now, we're going to go ahead and that tap that I've been using, now that we've got some pretty good wear on this tap, I'm going to feel less guilty. And we're going to grind about 1/4 of an inch off of this. And then I can get in there and bottoming tap out these holes a little bit to make sure that I can get that thread as deep in there as possible. So I'm just going to go over to the belt grinder, put a really coarse belt on to start with, and we're going to knock this back about 1/4 inch. I'll clean it up with a little nicer belt to finish it. Just use some water, keep it cool. So we'll get this shortened up about 1/4 inch, and then we'll see how that's going to work to just bottom out those holes. So that is our next step. Alright, I'm 1.238 right now. I want to go down to about 1 inch. Alright, I'm about 68 thou left to go, 50 thou left. And we'll put a finer belt back on there and clean that up a little bit. Alright, we're just over 1 inch there now. Just take a little more. Definitely doesn't come off as fast as it did with that 60 grit. That's pretty amazing. Alright, there we go. Get to a sharper part of the belt. So we're just under 1 inch there now. That should give us what we need to get some extra thread on there. Alright, well, I'm right at the bottom of the tap there now. Yep, that is just about getting us to as far as we can go. Alright, let's see how this compares. Alright, so right about there is what I was getting initially. And then we pushed a little further the next time around, then I made it all the way to there. And now we've got about another 1.5 turns maybe. So it only gave us, another thread or so. But that gives us just a little over 1 inch of travel. Inch is what we're going for, and that just gets us there. So I think if I just push all these chucks, that extra thread down there, we're gonna get just that extra inch. So then, all right, so if I can have that much travel, we'll give a little bit of room so your chuck never bottoms out. That gives me a little bit of space. We'll give it a little bit of extra there. Make sure there's a gap. 1 3/4 gives me enough. All right, that gives me what I need. We'll get the bandsaw out. We'll cut all this ready rod down into 1 3/4 inch chunks. We've got to drill all those out, and then we'll start working on the screws, and then we'll get these over in the CNC and get our bolt circle on there. So let me finish tapping the rest of these chucks as deep as I can, and then we'll get over and start drilling some ready rod. All right, before we move on to our next step, quick pickup from where we left off last time. So we finished these drill chucks, and I think I pushed the tap just a little bit too far in these. So this one still turns nice and easy like a drill chuck is supposed to. You know, all good, no problem there at all. But I get into some of these other ones, and they are tight. Like, it's kind of both hands. If I mount it on a shaft and hold onto it, I mean, you can still do it by hand, but it's pretty tight. So I think we maybe pushed that tap in there a little bit too far and just kind of rolled over where those chuck jaws move in there. So I'm going to try to mount this in the 3-jaw afterwards and try to run it back and forth a couple times and see if it loosens up. Otherwise, may have to replace a couple of these chucks and do them again. So that's just part of prototyping. Things like that happen. Figure it out. You know, I kind of checked a couple out and they seemed okay, but got a couple of them that are a little bit snug and tight as well. We'll figure that part out, but now it's time to move on to getting our hole in this threaded rod. So we're going to cut this into 1 3/4 lengths and then drill our 31/64 hole through the middle of these. So that's what we got going on here this evening. Got the saw inside. I'm hoping that while it's cutting off a piece, I can be drilling on the lathe right next door and we can get these things knocked out fairly quickly. So let's go ahead and get this first one cutting. Cuts through there pretty quickly. No issues with that stainless. All right, let's get this over in the lathe, start drilling. Well, there it is. Drilled through, threaded all down the outside, ready to be welded. Those should knock out fairly quickly. Should be good. Well, YouTube, good place to pause here and talk a little bit about how this project is going. Sometimes when you're prototyping, it is a good, humbling experience, and this particular project has been no exception. So making the base plates, making these parts out of the stainless, that went pretty smooth. Haven't really had any significant issues with this part so far, and we're about to put this in the CNC and drill and tap the bolt circle in there, so hopefully that goes smooth. I've got a jig plate set up in there. We're gonna bore a hole in the jig plate. I'm gonna tap it by hand, just use a piece of the threaded rod. We'll be able to just mount these onto the jig plate, secure that into the CNC, drill and tap that bolt circle. So hopefully that part goes pretty smooth. The humbling parts of the experience. So these drill chucks, one of the first steps we did was drill and tap those. I put them in the vise and then I finished hand tapping them. Well, I pushed that thread a little bit too far in there, and these are now they're just too tight. Not gonna work. You know, I just went ahead and ordered some more of them. I'm not gonna send anybody out using a part like this where you've got to use a chuck key to open it and close it all the way. So a little bit of cost of prototyping right there. We'll do some more of those and just not gonna thread them back in there as far. I think just to show you exactly how this works and just so that I can verify exactly what I've done inside here, probably gonna cut one of these apart. It's actually crimped on right here, so we'll take and put it in the lathe and I'll just cut that end of that piece off of that sleeve. Then I should be able to pull where it's pressed on there apart and we'll look. And I'm pretty sure that what I've done is on the back side of the holes where those jaws go in there or move in there on an angle this way, where those jaws move, we kind of rolled a burr over on the back side of that hole, and that's what's causing it. If you put the chuck key, it is turnable, but it's just snug tight all the way. So we'll cut one of those apart, look at it, and make sure that we know exactly a little better what we're doing before we drill and tap the next batch of those that are coming in. And then the other piece, you know, we modified the thread a little bit. There was a metric thread on the original one of these that I had. Went to a standard thread. Once I drilled that bore out, clearly just doesn't have the strength. So on the second one that I drilled, just the pressure from the drill bit actually pushed the end of the piece off. So then I went and stuck it in a vise and I just grabbed it with some pliers and I was able to torque that apart. So obviously that's not gonna work very well for a puller if it pulls apart that easy. Finally did the math on it, and on the thread depth, and it's anywhere from 7 to about 25 thou potential difference between the two threads. Just, you know, you've got variability between those minor diameters on threads. So that up to 20 thou difference clearly has a significant strength issue on this. So we've got some options. I've got the customer verifying if we can just go smaller on the bore, get some of that strength back. Worst case scenario, maybe we're gonna have to go to a finer thread, either go back to that metric thread or just go to a finer standard pitch thread and modify it a little bit there. Base plate should be good either way, even if I have to, I mean, the piece is getting welded in there, so even if I just have to bore it out so that we can slide the piece in to get welded, or I can potentially retap it into a finer thread and it'll still have some thread holding that on there when it gets welded. Either way, the base plate should be good, but we've got to modify this part and we got to redo the chucks. So there's kind of a quick update on how the project is coming together. Still making headway, but again, with prototyping, sometimes you run into these little snags. I try to think like an engineer, but I am not one, and sometimes you miss what you think is going to be a simple piece and you don't put enough thought into it, and that's kind of what happened to me here. But let's go ahead, take a look at the CNC. I've got a block in there. I'm going to use a chunk of aluminum, so I've got an aluminum block. I've already sort of faced the sides of the block, got it in there nice and square, so we're just going to probe it and line up where I'm going to drill and bore this piece. I'm also going to step it down a little bit so I have a little bit of a lip. That way if I use this jig plate again, it'll be really easy to go in there and line it up and make sure I've got a little bit of extra clearance as I'm drilling and tapping through here, just to make sure I'm holding that up out of the way a little bit. So let's go ahead, take a look at the CNC, get this block probed in here, and let's start making some more chips, get this project moving ahead. Let's go. All right, I know where I've got the camera set up. This time you're looking at this from the side, so you're not watching the dial move, but that's all right. We're just gonna knock this probe it out really quick here, and then we'll get some cutting. All right, we are probed and ready. We're just turning a boss that's gonna match, bore the hole, and then like I say, we'll tap that by hand. has made pretty quick work of that. We cut down that pocket, so we've got a little step on there. We'll tap that hole, and then we'll set our piece, and we've got plenty of room to get in there and drill and tap that bolt circle on there. All right, let's get in there and get that tapped by hand, and we'll be ready to set this up and start drilling and tapping. All right, that tapped very nice. I maybe could have got away with power tapping that in aluminum. I think I tried once power tapping a hole over 1/2 inch, ended up getting something stuck. Kind of a little bit leery of it. It's really a pain when you jam it with a tap in there. You have to try to get the collet undone. I think I ended up having to take the piece out of the vise is how I had to get it off, because you can't reset Z when it's stuck on a tap. So anyway, big holes. I find it safer, easier. Just go ahead and knock that one out by hand. And there we go. We're going to be able to thread our piece right in there, lock it on, knock these out. All right, I don't think I need it super tight. Got a larger one of those, but I think I'm only going to get the same amount of contact on the rubbers. I'm not sure it'll matter. Oh no, this one definitely gets a little tighter. All right, so I've got this set up off of the center of this bore, Z height on top. I probed that bore off the edge of my block here, but I know that I'm exactly 5/8 in and 5/8 over. So I'm going to go ahead. I'm already probed on the block. I'm just going to set my X and Y at the 0.625 and 0.625 and zero both of those out. And then I'll check my Z height on here, and we should be good. Should be able to just unscrew, screw the next one on, and knock all of these out without having to probe anything else. All right, so there's my 625, 625. It's lining up on the center of that visually, which is all I'm really checking to make sure, but that is dialed in off of that piece. So I'm going to reset X and Y to that point. And now let's get over here and get our Z set. All right, we got it probed. Let's go ahead and see how this stuff drills and taps. Let's check it out. Oh, and there is why the power tapping can be a challenge. I saw it slip on there, so don't think that's going to come out of there very nicely to be able to get that off. So we'll figure out our best way to get this out of there now that I hit the E-stop on it. Yeah, this stainless stuff, it is some tough material, I tell you. This stainless is pretty tough stuff. Made it down in there, it started coming out, but I don't know, maybe it was coming out good, but it looked like it slipped to me, and I don't want it jamming trying to pull up against those threads. I know I can undo the vise and I can reprobe my block and do it that way, and honestly, yeah, I think that's my safest, easiest bet. All right, we got that undone. I'll reset Z first. And I know we're clear, and then I can reference X and Y. All right, well, there we go. This project continues to create some fun little challenges, keep things exciting. All right, so for sure this one will finish tapping by hand, and I may just, with the other ones, I think I'm just gonna go less in and make sure I get that tap started nice and square, so I'm just gonna change the depth of how far I'm going in there with the tap, and we'll try that and see how it works. Yeah, even there, I mean, it only went in a few threads, but even just the drilling, you can see it already pushed out the bottom of those, generating a lot of heat, even drilling that short little bit. Maybe I need to slow that drill down. Maybe that'd help out a little bit too. Definitely, without having flow through the middle coolant, pushing up a lot of heat on there, drilling those holes. All right, probably have to sharpen that drill bit before I do the next one. Maybe slow the feed down on that drill and also work on that tap setting. All right, see you back in a bit. All right, we are back. So I got this one done. I finished tapping it by hand. That worked out fine. I did notice that because we're on a thread, it's got a little bit of play. My bolt circle wasn't 100% lined up, so I went ahead and made a little collar to put on there to make sure that as I'm tightening those down, they do center up on where I want them to be on that X and Y. And I also shrunk that bolt circle just a little bit just to make sure the heads of these bolts are going to be inside there. So this one going to be a little bit off. We'll get this next one on, and like I say, it should center up a little bit better and should get us right in there where we want. So all right, so it should be centered up on the collar. I'm gonna go ahead and pick up my Z height now that that's in place. We'll get that reset. I've already got my X and Y set on there. So we'll just re-pick up Z, and I changed the formula a little bit. I'm gonna take a 1/8 carbide drill and punch all the way through instead of doing the center drill and then the other one. I'm gonna do a 1/8 carbide drill, punch that all the way through, and then sort of ream it out with that tap drill size. Hopefully that allows coolant to get down there a little better. Keep it a little bit cooler on the ends while we're doing that, and then I'm gonna tap less, and hopefully that tap will be happy just going in there about 100 thou less and just get them started, and I'll finish tapping them by hand. I do still need to pull that drill out of there and just sharpen that drill, make sure that I didn't cook that last time from drilling these holes. So I'm going to touch that, sharpen it, reset the height on that, and we should be ready to run this. All right, let's see how our new recipe does here. Let's give this thing a run. Well, the formula worked. It's definitely barely tickling the start of a thread in there, so it's almost not tapping anything at all, but it seemed to drill a lot nicer. Let me see if that just gets my tap started out square, and let's see how our bolt circle looks on this one from a centered up perspective, and then we'll knock out the other 7 of these that we've got left. I think that definitely looks better on the bottom side. Some heat on that 1/8, but a lot better looking drill going through on the other one. From a centered up perspective, we got 156, 155.5, 165 on that one. So still a little bit of variation, but not near as much as we had before. So I think that ring did our job there. Let's go see how that does to hand tap. We'll knock the rest of these out. Okay, I think I am happy with that. I'm gonna go set it so that it taps a little bit deeper. Actually, what I'm gonna do is I'm gonna double check the tool setting on here and make sure that when I reset the Z last time that didn't actually move a little bit in there when I thought I saw it slip. So let me make sure that the tool height on that is correct. I may set that to tap a little bit more because, like I say, it barely even started cutting the first thread. So still hand taps pretty easy. I think it just really likes tapping fluid better than coolant in this stainless. But I like that. Bolt circle is a perfect size. Those bolt heads are just inside the edge, inside the flange. We have got a good recipe. Drilling it out that way seemed to work. So let me just go in there and let's verify the tool height, maybe make it tap in there an extra, 50, 60 thou so that I get a little more thread to get started, and we will knock the rest of these out. right, I like that. I definitely have at least one good start of a thread in there. I don't know if you'll be able to see it on the video. It looks like it hesitates when it's stopping and backing up in there with that tap, but I let it run that time. We didn't have a jam. Nothing got stuck, so let's knock them out. Let's crank out the rest of these. Alright, well I guess that answers that. It really is that close to sticking even on that tap going in there only that far. So I guess after 8 of these my tap is a little bit dull. It just froze up on that last one and I had to do the E-stop again. So I was starting to think to myself, I'm like, man, maybe I really could have pushed that tap in there a little further, but I think I just answered that question and I was pretty much maxing it out. So I'm not going to go and reset this entire thing up to do those last 2 holes. I'll just do those last 2 holes completely by hand, and let's head over to the vise and let's knock out hand tapping the rest of these. So I would say we figured out our decent formula. That worked a lot better this time around to get those this far. So let's go finish them up with hand tapping, and then we're going to move on to that last step in our operation, which is making some pointy screws. All right, see you over at the vise. That's about perfect. Just got enough started in there. Takes a second to finish it off. And like I say, this stainless really seems to like a little bit of rapid tap cutting oil or something instead of the coolant in the machine. Just takes a couple minutes to get in there and finish those holes up. Alright, on the one side I'm just getting rid of the sharp edge. On this side, where the screw head goes in from, those screws aren't threaded all the way up to the head, so I'm trying to go a little deeper to help those screws come close to bottoming out in here. And there's the last of them. Go hit those with some air, and then we're going to head over to the lathe. We'll get our little jig made up so that we can start turning these bolts into pointy bolts. That's what's next up. See you over at the lathe here in a minute. All right, so here's our little jig that we're going to make to hold these screws and make them pointy. Now I just need a counter bore in there bigger than these screw heads. Let's see, 5/37. And well, we're gonna punch it a little bit with this tap drill that we had for the 5/8. And we'll get our boring bar in there, flatten off the bottom. There we go. We got our little jig to hold our screws. Now we're going to be running this in reverse to make sure we're tightening that as it's going. And let's figure out what angle we want to set our compound on for those other screws. So I'm just going to hold it square, adjust my compound till I'm about lined up on there. And I think that'll give us a pretty close. So if I hold this down here and just turn my compound until I'm lined up on the side of that screw, we'll kind of go to the nearest degree, and that should give me about the same as what these ones are. All right, pretty much right on 25 degrees. It's a nice even number, I like it. There we've got one. We get a measurement off of there for depth. We'll knock out some more. There we got one of these done. Let's try and get a little better camera angle in here and get a better look at what's going on. Put the points on the rest of these. Go in here, get my depth set. Try to get these all pretty much the same length. And we're running these in reverse. So first I'm going to face it off to that length, clean up the end a little bit, and then we'll run our taper on there. we're going for a depth of about 650, 6485. So yeah, we're right in there. And there we got a couple of them done. Got about 18 more to go, so we'll be knocking these out for a little while. I'll probably film a couple more and then I'll get the camera out of my way and just get these knocked out. There, that worked a little better to keep some point on there while I'm hitting those with the emery cloth. Double check our process, how we're doing here. Getting good consistency. All right, let me turn the camera off for a bit. Let me knock out some more of these, and I will see you back when next up, once we get all these screws done, I'm gonna put one of those chucks on here. So I'm gonna cut one apart. We'll take a look inside, confirm that what I think is going on is what's going on. We'll be ready for when the new ones get here. All right, we'll see you back here in a bit. All right, I got all those screws done. They're all nice and pointy. Now it's time to really take a good look at what's going on with these chucks and see if we can figure out what's happening with these so that we can not do it again, I guess, essentially. First off, I'm just gonna run this back and forth a couple times, see if it loosens up any. So it gets loose when the jaws are all the way out. You know, right there, it moves nice and starts getting tight. Let's see if it'll loosen up a little bit if we go back and forth a couple times. It's movable, but I mean, you're trying to hold that onto a rod. I mean, it's in a lathe, you can barely get it to work by hand, so not very functional. All right, these ones are crimped right here. I'm just gonna go ahead and cut that crimp off on there, and then we should be able to pull this cap, get a look inside, and I'm pretty sure that we've just rolled over on the backside of the holes where the jaws move. Let's go ahead and take a look. We've got new ones coming. May as well dig into one of these and see exactly what's going on. All right, I'm gonna open this all the way up so that it's not trying to spin when I try to cut it. I think if I just get in there with the parting tool, that should work pretty well. Let me square this up since I have adjusted. Cut off pretty clean. I don't think I'm all the way through the groove. I think I need to back up, notch that back just a little bit more. think I'm through there now. Should be able to go hold that in the vise, pound that through, and press that off. So let's head over to the vise and see what we've got. Well, that came apart as easy as expected. Even easier, I think. All right, so here is what we've got. If you've never looked at the inner workings of a chuck before, got this cool split nut on there. So that's what goes together. This cap is pressed on top of those to hold that split nut together. And that goes in threads, almost just like the scroll on a 3-jaw chuck in a lathe. And that nut just scrolls around on those pieces. So we've got lots of grease in there. All right, so the jaws themselves look fine. No issue with those. We're not hitting those at all. The split nut seems fine. I don't see any issue with that. Where I ran that tap in there deep, it's gonna be really tough to line it up to see. There we go, maybe if I get a little light coming in from the backside here. But it just rolled up a little bit of a burr on the back edge of each of those holes. So even pushing those jaws out, it was a little bit snug. So I'm gonna run a file on the back side of that, see if I get those to slide in and out of there a little easier. All right, so these are like a 3-jaw chuck. You can see the little grooves on the back here. So we're gonna go with this is number 1, this is number 2, and this is jaw number 3 based on where they start. So I probably should have numbered them before I pulled them out, make my life a little easier. I wanna get them sliding in there, even easier than that. All right, as I'm going to put that back in there, I can see it's not just right at the very edge. I can see where I've pushed up pressure further up into that hole even than I thought. So, I mean, I really need to make sure I tap a good 1/4 of an inch less than I did on this one. So I need to file back further than I did there. Now we've got free movement again up there. All right, let's see, that is number 1. All right, this chuck's not going back into service, so we're just gonna put a little bit of oil in here. We're not gonna put any grease in here. Go again with our jaw order. See if I can get these in the right order first try. Oh, there we go. We just get it around in the right direction. Okay, well, we're able to operate that by hand again. And no, we definitely don't have the jaws in the right order. So we got one sticking out way too long. All right, that still didn't fix it. Let's try switching these two around. Leave jaw number 1 in the same place. All right, we're back together there. Let's see if we got it closer this time. Hey, there we go. All right, we flipped those two around, and now we've got that coming in. Jaws are lined up, and that's coming in where it's supposed to. And we've got a chuck that is working again. Obviously not the way it's supposed to since we cut that piece off. Now that's sticking down there a little bit too far. So it wouldn't be a good functioning chuck to put into service. But we have figured out what our issue is, and hopefully if I just tap those other holes about 1/4 of an inch less, we shouldn't have any more issue again. And what the heck, we got to take a drill chuck apart and really get a sense of what's going on in there to make these things work. So pretty cool. All right, new chucks are coming. We'll drill and tap those. We still have some threaded rods to figure out the right bore size. And then I think we're nearly getting close to wrapping this project up. Definitely taking some twists and turns along the way, so I'll be excited to be able to get this one out the door. All right, we'll see you back here soon when we got some new chucks. All right, well, YouTube, we are back to see if we can get this project to a good wrapping point, get this wrapped up. So we got some new chucks. You can see how loose and free these chucks turn when they're new. That is what we're going for after we drill and tap that larger size hole in there. Running it fast enough to drill, I'm gonna have it kind of backed off and tightened up so that make sure the jaws aren't moving in here. But before I start tapping, I'll loosen this off, and that way I'll make sure that I can just keep checking it as I'm tapping and make sure that it's still spinning free in there. So that's the plan. Let's see if we can figure out the right depth to drill and tap these where we don't end up with a tight chuck when we're done. All right, that does does take out all of the original step that was down in there, but we're going to go into that same depth and leave a little bit of material on the front end. Maybe to see if that gives a little bit more strength, keeps our material from wanting to flare out on that chuck. All right, so about 850 is the depth I want to go this time. Let's see what that does for us. All right, that's definitely leaving a little bit of a step in there before it goes all the way through. I think I'm going to go just a little bit more. Still leaving a definite little shoulder in there, so I think that'll give us a little bit more strength material, keep that from wanting to flare open and jam like it did before. All right, so after drilling, clearly no problem. Got everything running free, turning easy. And I think you can see in there that, yeah, we still have that little step where I didn't drill it all the way through, so we got a little bit of a step in there to save as much material strength as we possibly can. But right now, it turns easy. All right, I can just keep checking to make sure that turns easy. I got you. Well, let's go blow some chips out of there. Okay, well, good news. That is exactly what we're looking for so far. Turns like butter, no problem. Let's see if we can use that plug tap and get a few more threads down there to our step and make sure that that's still going to turn nice and easy for us. All right, I also modified my plug tap a little bit more here. I shortened it up to where I've just about got all full threads. You know, it's got just a little bit of a taper on that first thread on there. I figure by the time we bevel the end of the rod going in there, that should give us about where it's going to bottom out. And from a depth, I should be able to just go until this last thread gets in there. That's going to be my 850, just about 900 for depth. So we know about where we can push this in there, and let's see how this is going to do to get those last couple threads. All right, so we should be getting almost another 1/4 inch of thread with this plug bottoming tap here. Yeah, about another 2/16 worth. Let's see how we do. All right, I think this first one, we're gonna just kind of tap it by hand and make sure I can get a sense of how it's feeling, how it's cutting. Feeling pretty good in there. As you can see, this tap handle just doesn't quite clear, so I can't swing it all the way around. Just using my jog to bring it around for me. That's still feeling great. I would say I'm hitting that shoulder there now. That feels like I'm pretty much right at the end. I'm at the depth I want. I can still turn it free. Let's see what kind of thread depth we're getting on our rod. All right, let me get this out of here and blow some chips out of there before we get a better look. Okay, well, good news. We're still turning free. If I look down in there, I still have a little bit of room before that step where I could maybe get one more thread. Just a little bit of taper on that tap, and it's hard to tell exactly, but I'm not quite hitting up on that shoulder. I'm coming up just a little bit short of it, so we maybe can push that just a little bit deeper, but let's see how we're doing on our threaded rod. All right, well, my piece of rod is 1.847, 1.850. I don't really have much of a bevel on these ones. Pretty much just cut flat. All right, it was a little tight getting that threaded on there. Might have to see where I got a burr or something in there, but let's see what we got for depth. So 1.850, and I got 1.20 inches left. So we've got a little, just over 800 thou of depth. We got pretty much to a little over 1 inch on them last time. So let's see if maybe we can't split that difference and get in there more like 900 thou. Not quite the inch, but I think more than what we were getting on the original part. I guess we're still about where they were on this one. So back on that original part, we were shooting for 1 inch, but this one really only had about 780 worth of thread and travel. So bottom line is we made it as good as what the original was. Let's see if we can get just a little bit more on there, but we want to make sure we keep that chuck loose. I think that might be about all we're going to get out of this modified tap. Well, I think we've got what we're going to get for these prototypes here. So I've got this where use some WD-40. I cleaned those chips out of there a little better. So now we're getting this threaded on there all the way by hand. So we've got good feel in there. Again, this piece is 1.845. Get that all the way in there. And we're under an inch here now, just under an inch. So yeah, about 980. So we're getting almost 900 thou in full travel on that thread. So again, a little less than the inch we had before, but our chuck rotates free. We solved that issue that we were having. I think we're gonna go with that. That's a little bit more than what's on the original. It operates, it works. Got a little step in there. We saved some of that material, and I think that's what we need. Bottom line is we didn't wreck it. We're good. Let's knock out the rest of these. Probably not gonna show that. I think you've seen enough drilling and tapping of chucks in this video, so let me just move on to get those done. Our last step, we're gonna come back and drill one of these. I've got a new bore size, so we'll drill a couple of these a little bit smaller, make sure it feels like we've got some good strength, and then he's gonna go weld a couple up and test it out. I'm gonna go ahead and drill a couple of these, and we'll assemble one of these, let you see how it sort of works and functions, and then we'll call it a wrap. So let's come back to drill a couple of these in a minute. Well, I got all those chucks done, and I tell you what, it is a fine line. It's about half a turn of that tap between whistling loose on there and just a little bit of drag on those chucks. Pretty fine feel in there. I was actually just finally got to where I was turning the tap, check the chuck, give it a little bit of a turn. Glad we took one apart, knew exactly what was going on inside there, and able to take care of those and get it done. So chucks are all done. We're gonna go ahead and drill these last pieces on here, and if I've learned anything with stainless on this project, it definitely likes a pilot hole in there to be able to keep the coolant going through. So I'm going to drill halfway from this side, a 1/8 pilot hole, turn it around, drill it from the other side. So pretty much have to bury my drill in there. I'll see if that shows up on video. Hard to come around from the side with the coolant flying. Don't want to get coolant all over the camera. But that's basically what I'm going to be doing, is punch it 1/8, and then I'll put my next larger drill on, drill that all the way through, and then run that last size through, kind of using the drill bit like a reamer, and just get it out to where I need to. Let's go ahead. I've got 4 of these to knock out until we get some more materials. Let's try them out, and we will have the prototype part of this project wrapped up. All right, let's get them drilled. All right, there's a good pilot hole through there. Really got to bury this drill bit in there both ways. So let's get all these pilot drilled, and we'll move up to our next size drill. All right, let's slow it down and get this next size in there. See how this will do. Okay, so we didn't get it too hot this time. We definitely kept it cooler by drilling that pilot hole, having coolant running through there the whole time. So overall, I'm liking how that is looking. I think it'll be in good shape. Well, there's how it's coming together. So we got our piece in there. Now that we're not tapping these chucks quite as deep as I thought I was going to, I can probably shorten that up a little bit, maybe go a little bit less on the threaded rod in there, make that stretch a little further. I think we could safely go a good 1/4 of an inch shorter and still make sure you have a little bit of room in there. Let me get these last 3 of them drilled out the rest of the way, and we'll get the screw feet on here and we'll get a good look at one of these all complete, and then we'll wrap this up. All right, clearly these can be a little shorter, so you know what? I am just going to go ahead and knock that out. I'm just take off a little over 1/4 of an inch here. I'm going to get them down to like 1.5, so that's going to take off about 300 thou. And I think we've got a pretty good cross section of material for strength in there. That's looking good. We'll give that a quick face and bevel here in a minute. Let's shorten up these other ones even before we drill them, since that's our biggest struggle on these. Let's make them shorter. Well, there we go. All 4 of those tubes are done. Okay, let's go ahead and get one of these things fully assembled and wrap this sucker up. Well, YouTube, that's going to be a wrap on another project here in the Blades to Be shop. Appreciate you joining on this one. I know this project didn't run as smooth as a lot of projects do, but hey, let's be honest, that learning, that growing, that problem solving, that's pretty much what keeps most of us coming back to the shop anyway. So really happy with how it turned out. This was our original design that we had. Tried to figure out how we're going to modify that and get there. Didn't even have a chuck that went on this one to make it complete. And here is our now finished product. So really happy with how that turned out. We've got our spiky feet on the bottom. That still needs to get welded on the backside to kind of match up with how this original one is. But he's gonna get those TIG welded on there, and then we've got that chuck mounted on there, so you'll be able to attach that chuck onto something, and then as you're unwinding, this will basically unscrew off of there and be like a puller and accomplish what this thing is meant to do. So happy with how it turned out. You know, almost more lessons learned in this project than I can even keep track of. Clearly, a lot to learn with using stainless. It definitely likes coolant, likes some pretty high feed rates, and just you gotta stay in front of the heat on it. It likes to work harden a little bit. A lot like working with titanium, only seems to hold the heat even more than titanium does. And then, you know, a little bit about you're gonna modify threads, you're gonna do things, just you gotta think a little bit more like an engineer. Do all the math on everything, make sure you understand exactly how your design is going to come out. So a lot of learning on those pieces. And then on these drill chucks, you know, tapping in there and just pushing them a little bit too far, making the threads a little sticky, making the jaws a little sticky, but it was kind of fun. Got to pull apart a drill chuck, understand how that worked inside. So again, a lot of learning through this project. Probably didn't give this enough respect and credit on the front end of on the design that went into it. Yeah, I really enjoyed it. I hope you did as well. For those of you new to the channel, I encourage encourage you to get out there, check out the other videos on machining, welding, knife making, just everything else going on here in the Blades to Be shop. For those of you already subscribed to the channel, I appreciate you coming back to watch this one. Till next time, I hope you're out in your own shop working on some projects of your own. I'll be here in the Blades to Be shop working on that next video for you. Till then, y'all take care. Thanks for watching. Subscribe for more.